Question 1. In this question, remember we're looking for the test for hydrogen gas. This is the gas produced when a metal is put into an acid. These bubbles are hydrogen, and you test for it with a lighted splint. The squeaky pop is the classic test for hydrogen. This part of the question is looking at the test for carbon dioxide gas. This is the gas produced when a carbonate is added to an acid. Pass it through lime water and it'll make it go milky white. For part B, to find the pH of a substance, we either use a special pH meter or some universal indicator. Universal indicator might come as a solution, which you add to the liquid, or it might come on these papers, but either way you'll still get these range of colours, acid around to alkali, with neutral around about here. So this answers the next part of the question. If the paper went red, we can assume that it was an acid. Don't forget, acids can be strong or weak. Alkalis can be weak or strong, and neutral is pH 7. Question 2 relies on knowing where metals and non-metals are in the periodic table. Apart from gold and copper, which are kind of a yellowy brown colour, all metals are silvery. Metals are found to the left hand side of the zigzag line starting in period 3 of the periodic table. Most elements are metals, so aluminium is a metal. Part B is about hazard symbols, and here is a poster from the corner of the lab, the chemistry lab. Acids and alkalis tend to have these symbols on the bottles, and in this case the I or the question mark or the exclamation mark stands for irritant. As a rule, we handle acids and alkalis with goggles on for safety. Part C of this question requires close reading. If a substance is a molecule, there must be more than one atom, and so only these possibilities could be the answer. In chemistry, we use lowercase numbers in a formula, so this is the one we want. And a hydrogen molecule will look something like this. Again, for part D of this paper, the wording of the question gives us some clues. Since sulfate is in the name of the substance, it's telling us it's really come from an acid that's been neutralized, so it's a salt. So, the word equation for making aluminium sulfate has to have sulfuric acid in it. The substance that reacts with sulfuric acid could be aluminium metal, or it could be aluminium hydroxide or aluminium oxide or even aluminium carbonate. But in this case, aluminium metal on its own would be simpler. Whatever substance we choose, there will be another product made. In this case, because it's just the metal on its own, we get hydrogen. Remember, the test is to use a lighted splint and the gas explodes with a squeaky pop. Question 3 starts off mentioning group 1, and an example from group 1 is potassium. Remember, the protons are found in the nucleus, here they are, and that is the atomic number, so our answer is 19 protons in the nucleus. We also know that atoms are neutral, so if there are 19 positive protons, if we count up all these electrons in the outer shells, we'll find that there are in fact 19 as well. So that's our answer. They match each other, plus and minus, it's neutral. The question goes on to make the point that both elements are found in group 1 of the periodic table. The group number depends on how many electrons are in the outer shell, so we can see here it's 1 for potassium, and if sodium is in group 1, it must have 1 outer shell electron as well. It's also worth remembering that if elements are in the same group, like these are, then they'll have very similar properties to each other. This question is about isotopes, and here's a simple example of lithium. It has 3 protons in each nucleus, but the number of neutrons are different. In the first case it's 3, in the second case it's 4, in the third case it's 8. These isotopes are not equivalent to each other, they're there in different quantities, and if you average these numbers but take account of how much is present of each, you end up with a number like this. So whenever we see atomic masses which are reported to decimal places, it's probably because they've averaged some isotopes to get the answer. So the atomic mass is 35.5. It's clearly not the whole number. So to arrive at 35.5, you must have taken an average of the different isotopes, and each isotope will have a different number of neutrons present.